Welcome. So let me show you how you can build a very simple micro experiment using Alter Ego. Alter Ego carries with it a shorthand functionality that enables you to run a very simple treatment variation on a single large language model. So let me show you how it works. First of all, let's import all the available agents, although we are only going to use one of them in this video. Then let's import the filter that we are going to use for now, which is called extract number. And let's also import the actual function that enables this shorthand functionality, which is called factorial, because it enables you to run a factorial design. The only difficult aspect here is to build what's called an agent factory. So an agent factory returns a thread on which an experiment will be run. Okay, so how this looks like is as follows. It's a function without any argument. And then this function, perhaps after doing some additional computation, but not necessarily, will return one of the threads that are built into Alter Ego. So in this case, we are going to use GPT-4, which would look as follows: Alter Ego agents, GPT thread. We are going to use GPT-4 with a temperature of 1. And here you could use all other kinds of agents and threads that are embedded into Alter Ego. And now we can actually write the prompt that should vary along with a treatment variation. So this is one example how it could look like. You could say, please estimate the public approval rating of politician during the time of their presidency. Only return a single percentage from 0 to 100. So the most interesting aspect here is this and this variable. So we are using a templating engine called Ginger 2, which is extremely powerful. And this enables us to vary these parts of the prompt alongside a treatment. And let me show you how to define such a treatment. So to just use the shorthand functionality to create an experiment with certain treatments, what you could do is simply say factorial of the prompt. And what do we want to vary? Well, first of all, we might want to vary the politician. So for example, George W. Bush. And the second one could be Barack Obama. And furthermore, what we also want to vary is the time of their presidency. So here we could say, the first year and the 8th year of their presidency. And what Alter Ego will do, it will create a 2x2 design. And what we call as scientists call a 2x2 design. And it will combine each politician with each time. And then it will execute this prompt using the agent, which will, give a certain result, which we can then filter. And to actually do that, what we need to do when we run the experiment, we need to say .run, and we run it using this agent that is returned by this function. And what we want to do is we want to extract a single number from the return value, from the response of the large language model. So what we can say is extract number. And we only want to run it once. Now this will actually already give us all the data. So what we want here is we want to say data equals this design with this treatment variation. And we run this using the agent specified earlier. And we extract a number from the response. So let's actually go ahead and run this. Let's save this first of all. And now we can say Python -i, which stands for interactive mode, first experiment. Let's run this. And after a couple of seconds, we are already done. And now what we can say is data. And here now, what we get in return is a list of dictionaries. And this enables you to pass the output forward to a data analysis package, as I will show you in a second. So what you see here is you get a list of all the, treatment combinations. And for each partition and each time, you get the result as, predicted or as estimated by the large language model, by GPT-4 in our case. Okay? So, for example, what we could also do now is we could say, well, import pandas as PD, and we could say PD data frame data. And now you see our micro experiment, its results nicely displayed as a pandas data frame. And of course, it should be quite obvious that you can now take this and do all kinds of analyses or whatever you want with this output. Of course, you need to remember that there is some sort of stochasticity in there, and if you run this multiple times, you will get different results. By the way, if you do want to run this micro experiment multiple times, you can simply say times 10, and then this 2x2 combination would be run not just once, but actually 10 times. So you would get 40 rows as an output, 40 dictionaries, which you can again turn in a data frame. And again, you can use this for whatever you want. Okay, this is of course just a very simple example. Now, it actually turns out that you do not need to specify a filter. Because if you do not use a filter, then Alter Ego will assume that the response by the large language model was in JSON. Now, JSON is a text format which is independent of any language nowadays, and that can be used for data exchange. And this is quite useful. So let's actually do that. Let me remove the times, and let me also remove extract number. We can also remove the import. We can quit Python. And what we can say here, we can say, please return a response in JSON, like this. And here we would put in the JSON that we expect the large language model to return. Now, JSON expects the attribute names to be in double quotes. So let me actually change this string to single quotes to not add on to any confusion here. So what we will say is we want this sort of JSON, we want approval, and here we say put in the value just here. So this expression is a comment in JavaScript where JSON originates from, and this will tell the large language model to simply put the value that we want into this position and to return JSON like this. So let's actually run this. And after a couple of seconds, it will return at some point, and here it is. And now again, let's just say import pandas as PD, pd.dataframe data. And now you see that the column name changed from result to approval. And that is because if the large language model returns JSON, a JSON object, then actually each column will be just, put to each row as it should be. And I will show you an example of that in a second, another example. Okay, so that's how you can actually get the data straight from the large language model. If your language model supports JSON, you can very easily get multiple columns. And, again, you can carry on this data frame forward to whatever kind of analysis or application that you want. Okay. So let me actually show you something else. Now let's do a little bit of an exercise here. What I have is actually the following file. And this file contains all 93 winners of what is sometimes called the Nobel Prize in Economics, quote unquote. Okay. And we have 93 people here. And what I want is I want to change this sort of unwieldy format, which is very strange because there is no year. The names are sorted by first name. Doesn't make much sense. But I want to take this and using the shorthand, variety of Alter Ego, you can turn this into actually usable data very simply. So let's do that. And first of all, what I want to do here is I want to read in the list of Nobel Prize winners, and I can do that using the following code. I can say with open Nobel txt as f, and I can say Nobel equals f.read.splitlines. And what this does, it gives me a list of Nobel Prize winners from this file. Let me actually show you what this does. So if I execute Python and I do this and then this, I get a list, and you see inside of this list is everyone from the file, sorted in the strange way that I just mentioned. Okay? So what I want to do with GPT now is the following. I want to say, here is a winner of the Nobel Prize in Economics. Now I want to say person. And we can add a new line perhaps here at this point, but that's not necessary, strictly speaking. And we could say, please find out the year that they won and extract their first name and last name. Only and exclusively return JSON like this. Now let's think about what we want. We want the first name, and this will be associated with some sort of value. We want the last name, and we want the year when they won. So let's do this. Okay. And then in our experiment, actually, quote unquote, although it's not much of an experiment this time, we will just say, person is basically noble, meaning that every one of these people in this file, will be put to the test, will be put to the GPT-4 model. And GPT-4 is then supposed to return JSON like this. And as I showed you earlier, Alter Ego will automatically process the JSON and put it into, a nice usable format, hopefully. Okay, so let's save this and we can run this. Let's run this. So this will now take a little bit longer. So after a few seconds, we have now completed. And let's take a look at data. And you see here for various people, the first name and the last name was extracted. And you can, take a look at it. We can also convert it to a data frame. So let's actually try that again. So here you get it. Now you see that result equals not a number for the people where the extraction was actually successful. The reason result exists is because what is done here is not exactly, JSON.loads, as a Python expert would understand. But it's actually wrapped in a try except block, which means that, if the language model sometimes doesn't return JSON, or your filter returns an exception, raises an exception, then, it will be put in as result equal none, okay? Because the problem in this example, which I ran earlier, is that some people got the Nobel Prize, after the knowledge cutoff of GPT-4, and those will be, not known to GPT-4. And those will be denoted as result equals none. So the result count does exist if the filter failed in a certain sense. And but you can look at this data and you will find out that the results are mostly correct, or maybe even wholly correct. Of course, you need to be always a little bit careful using this technology because of the, again, stochasticity in responses. It can also hallucinate and so on. But in principle, what we did here is we basically fed GPT this list of unwieldy names. And what it did, it extracted the first name, the last name, and the year for the people where it was able to do so. So that showed you how to run very simple micro experiments using Alter Ego. And enjoy and have fun. Thank you.